Alright, tonight what we're going to be talking about is how to fill out a BCA chart when it's not just mole to moles. Instead, we're going to be focusing on moles to grams or grams to moles. So remember, what is most important is that whenever you use your BCA chart, what you're going to need to do is make sure that you are in moles. So if you start with moles, then you might have to go to grams, or if you're at grams, you're going to have to convert to moles and then go from moles in your BCA chart to moles or whatever. But remember, how do we use anything with mass? Is we're going to use those conversions of the molar mass equals 1 mole, and we're going to set up the proportions. Alright, so I think it's easiest just to go straight out and do a problem. The great part about these problems is that you're only going to need to fill in from now on the columns that are given or are asked about directly in the problem. So it says how many grams of hydrogen gas, so I'm figuring out grams of hydrogen gas, will be produced if 2.5 moles of calcium hydride react with excess water. So in essence, I don't care anything about these two columns because they are not asked about in this example problem. So I'm going to actually ignore them. Now I'm going to start filling in my BCA chart, anything that I know. Well, I was given 2.5 moles, so I can go directly into the BCA chart, and I know my before was 2.5 moles for calcium hydride. I'm going to assume that it goes to completion, so I'm going to subtract 2.5 moles because they are on the reactant side, which leaves me with 0 moles of the calcium hydride in the end. Alright, so I'm going to start with 0 moles of the hydrogen. Okay, so I need to figure out how many moles, if I lost or used 2.5 moles of calcium hydride, how much hydrogen could I produce? So in order to do that, I'm going to need to figure out my C, which is using my proportions. So I know I've got 2.5 moles of calcium hydride, and I want to figure out how many moles of hydrogen is that. Well, I don't know that directly, but what I do know is that there is 1 mole of calcium hydride needed for every 2 moles of hydrogen that would be produced. So when I cross multiply that, I get 5.0 moles of hydrogen. So I know that if I lose 2.5 moles, I'm going to gain 5 moles of hydrogen, which means 0 plus 5, so in the end I would produce 5 moles of hydrogen. But if I read the problem, it doesn't ask for moles, it asks for how many grams of hydrogen would I need to do. So what I'm going to do is I need to convert my moles, which I produced 5 moles, and I'm going to need to convert that into grams. So I'm going to set up a proportion just like we did during the mole unit. We've got 5 moles of hydrogen, and I need to figure out, hey, how many grams of hydrogen is that? So what am I going to do? I'm going to use the molar mass. Okay, so moles has to be on the top, just like for the previous unit. So it's going to be 1 mole of hydrogen is equal to the molar mass. Remember, we have 2 hydrogens, each with a mass of 1, so that would be 2.0 grams of hydrogen. I'm going to cross multiply, and I get 10.0 grams of hydrogen. But rounding to the correct number of sig figs, I'm going to reference my problem, and I've got 2.5, which is 2 sig figs. So my answer should be 10 with a decimal point. So get rid of that. And I'm going to have 10 grams of hydrogen is how much I could produce. Alright, the next one, once again, if I start with mass and I need to find something with that, what I'm going to need to do is convert first to moles and then use my BCA chart. Because remember, the only thing that can go in your BCA chart is moles. So how many moles of calcium hydroxide, so I'm going to find something about that, will be produced if 28 grams of calcium hydride react. So I'm given something with that. I don't care about this column of water, nor do I care about hydrogen in this case. And the reason why is because I'm only concerned about moles of calcium hydroxide produced from 28 grams of calcium hydride. So I'm going to set up my proportion. The reason why I'm going to need to set up my proportion right away is because I'm in 28 grams, and the only way I can use my BCA chart is if I'm in moles. So the first thing I need to do is convert my 28 grams of calcium hydride into moles. So I've got my 28 grams on top, and I need to figure out how many moles of calcium hydride that is. So I'm going to equal it proportionally to the molar mass. So grams has to go on top of calcium hydride, and if I add up the molar mass, I get 42.1 grams, and that is proportional to 1 mole of calcium hydride. So for every 1 mole of calcium hydride, I need 42.1 grams. So once again, I'm going to cross multiply like I did during the mole unit, and what I get is that 28 grams of calcium hydride is equivalent to 0.665 moles of calcium hydride. So now what I'm going to need to do is I'm going to fill in my BCA chart. This is how much I started, so I'm going to put in my 0.665 moles. I'm going to assume that it goes to completion, so I'm going to subtract 0.665 moles, which means that I ended up with 0. Now the nice thing is looking at the coefficients, I've got 1 for my coefficient in front of calcium hydride, and I've got 1 in front of my calcium hydroxide. As with always, the products, you always start with 0 of your product because nothing has reacted at the beginning. And what I'm going to do now is, because they have the same coefficients, I don't need to do any calculations. I know that they are going to gain 0.655 moles of the calcium hydroxide, which means 0 plus 0.655 is going to be 0.655 moles of calcium hydroxide. So now I know in the end that I produced 0.655 moles of calcium hydroxide if I reacted 28 grams. Now going off of sig figs, I have 2 sig figs with 28 grams, so this will translate to 0.66 moles. Alright, and now a mass to mass problem. Okay, so once again, I'm going to need to convert from grams to moles in order to use my BCA chart. Then I'm going to convert from moles to moles, and then finally I'm going to have to go back to grams of my other substance. Alright, so what you need to do is figure out what you're given and what you're asked about. So lead will react with hydrochloric acid to produce lead 2 chloride and hydrogen gas. How many grams of hydrochloric acid, so I'm asked about grams of this guy, are needed to complete with 63 grams of lead? So I know I've got 63 grams of that guy. So I don't care anything about my products in this case for this particular problem. So I am given 63 grams of lead. So what I'm going to first need to do is I'm going to need to convert that into moles in order to use my BCA chart. So I've got 63 grams of lead. I'm going to put it over X moles of lead because I need to figure out how many proportionally it's equal to. And what I do know is that the molar mass of lead is 207.2 grams of lead for every 1 mole of lead. So when I cross multiply, what I end up getting is that my lead, I am actually starting with 0.304 moles of lead. So I'm going to fill in my BCA. I'm going to fill in my B is 0.304 moles. I'm going to assume that it goes to completion, so I'm going to lose all of it. So it's 0.304 moles I'm going to lose, which means I end up with 0 moles of lead. Alright, unfortunately, when you look at the coefficients, they are not the same. I have a 1 in front of lead, and I have a 2 in front of that hydrochloric acid, so I'm going to need to set up a mole proportion now. So doing this, I know that using my C's, I've got 0.304 moles of lead, and I want to figure out proportionally how much is that according to how many moles of hydrochloric acid would that be. So I'm going to set up a proportion. I've got 1 mole of lead. I'm going to be using, once again, the coefficients for this guy for every 2 moles of hydrochloric acid. So when you cross multiply, you get that you would, if you use 0.304 moles of lead, you would need 0.608 moles of hydrochloric acid. So I know I'm going to assume that there's excess, and I'm going to assume that I'm going to end with excess. But what I do know is that I needed to use, so it should be a subtraction, 0.608 moles of hydrochloric acid if I used up that 0.304 moles of lead. Okay, now I figured out my moles that I use, but once again, that's not even the question that I asked about. The question that I asked about is how many grams that is. Sometimes it's beneficial to write what units you're asked about above the substance that we're asking about, and what amount or units we're given above the unit, above the substance that we're talking about. So like above the lead, I put 63 grams, and above the HCl, I put grams because I'm trying to figure that out. So now what I need to do, though, is because I'm asked about grams, is I'm going to need to convert this 0.608 moles into grams because I'm asked about how many moles that is. So I need to set up a proportion using, once again, the molar mass. So we've got how many grams of HCl. So we're going to set up the proportion. Remember, moles has to go on top on this one because I put moles on the top on the other side. So I'm going to put 1 mole of HCl on the top, and then I'm going to put 35.5 grams, which is the molar mass of HCl, on the bottom. When I cross multiply, I get 22.2 grams of HCl, which rounded to the 2 sig figs because of that 63 would mean that I would end up with 22 grams of HCl. All right, hopefully you understand a little bit on how to go for using the BCA chart from moles to mass. Basically, you need to convert into moles to be able to use your BCA chart, and from there, using the molar mass, convert to other grams or anything like that.